On today's video, we're going to take this rare IBM computer with a bit of an identity crisis and upgrade its CPU, its RAM, and give it a little bit of DOS-based multitasking. The original IBM PC model number 5150 was released in August of 1981. It came with a 4.77 MHz Intel 8088 CPU, and despite it being a 16-bit CPU, it had an 8-bit data bus. An extended version of the PC that supported hard drives came out in March of 1983, known as the XT or model number 5160. It looked very similar to the PC and also used the same 8088 CPU. In August of 1984, IBM made their next major update by releasing an 80286 based machine running at 6 MHz with a 16-bit data bus. This machine was known as the AT Model 5170. It had a totally different case than the PC and the XT, sporting a more flattened design. IBM sold both the XT and the AT side by side for a while. However, in September of 1986, IBM pulled a rather strange stunt and released the personal computer XT Model 286, or model number 5162. This machine is odd in many ways. It had the same case as the XT with its angled design, but inside was an AT, using the same 80286 CPU as the original 6 MHz AT or 5170 model. The 5162 was only in production for around 10 months, making it a pretty rare machine, but also the cheapest IBM machine that was capable of running a true multitasking operating system, including OS/2 and even some x86 variants of Unix. Due to the 286's capabilities, it was capable of addressing 16 megabytes of real memory, or up to 1 gigabyte of virtual memory. I've coupled my 5162 here with the IBM 5154 EGA monitor, which is also pretty rare. I'm also particularly fond of this 5162 as it was made in IBM's now long since departed factory in Greenock, Scotland. I used to live at the top of the road where this factory once stood. All in all, my 5162 has a pretty nice setup if I say so myself. But forever the hacker, we can always improve on such things, especially as you'll find out IBM deliberately clobbered this machine to ensure it didn't steal market share from other IBM machines. This video is sponsored by the very wonderful people at PCBWay. PCBWay are the leading electronics and prototyping manufacturer. If you've got an idea, you can use PCBWay to turn it into a reality. PCBWay can build PCBs from just $5 and build them for you in around 24 hours. Now, what I really love is that for people that suck at using a soldering iron, like myself, you can upload your PCB file and have PCBWay assemble it all for you. PCBWay also do 3D printing, CNC machining, sheet metal fabrication, injection molding, and so much more. They are widely reputed by us in the retro computing community as being the go-to supplier of your PCB needs. So if you've got an idea for an electronics project, why don't you give PCBWay a try at PCBWay.com? After all, that is the PCB way. We thank PCBWay for sponsoring Al's Geek Lab. Now, let's get back to the video. The 5162 was actually an improvement in performance over the original 1984 AT because it had zero wait state memory rather than the single wait state of the AT. This made an increase in performance of some 32%. It also shipped with 640K of RAM rather than the 512K of the AT, as well as a 20 megabyte hard drive and an AT style half-height 1.2 megabytes 5.25 inch floppy drive. I also added a 720K 3.5 inch floppy drive to my machine to complete the look. Some say that IBM released the 5162 because they had too many XT cases lying around and needed to get rid of them, but others say this is unlikely because it was introduced 7 months before the XT was withdrawn from market. If you know someone that worked in IBM and knows the real reason behind the creation of the 5162, I'd love to hear from you. Drop me a line in the comments below. I've had my 5162 for a few years now, and in my opinion, it's my favourite of the IBMs. I've owned the PC, the XT, the AT, and even the PS2. This one provides the power of the AT, but in the case of the XT, which I've always preferred for its retro looks. I think the AT is pretty industrial looking. What do you think? The main problem with the 5162 is that it's got the most puny of the 80286s, clocked at only 6 MHz, and despite its 0-weight state RAM, it still underperforms the second generation AT, released in April of 1986. That machine ran at 8 MHz. It also looks like IBM seemed to clobber the machine in order to make it hard to upgrade the CPU. This was probably a deliberate choice to make you buy the newly released 8 MHz AT, which only had come out 5 months prior to the XT286. Upgrading the CPU in the 5162 is not just a simple case of replacing the CPU and changing a setting. You also have to replace the BIOS, the clock, which is a quartz crystal oscillator, and depending on what chips you have on your system, you might also have to replace the motherboard chips marked U68, the 286 bus controller, and U79, the clock generator. But more on all of this CPU upgrade stuff in a bit. I always thought that to be able to do anything really worthwhile on a 286 machine, it was always going to have more than 640k of RAM, regardless of what Bill Gates said. A major goal of mine was to be able to run multiple programs at once, either with some software called DeskView or with Windows 3.0. Windows has always been pretty sluggish on a 286 with 6 MHz, especially with only 640k of RAM. Most tasks are generally impossible with that low an amount of RAM. DeskView is a text mode multitask windowing tool, which, if given sufficient RAM, it could be much faster to work on than Windows 3. Even if I couldn't upgrade the CPU, I'd already tried DeskView and Windows 2 and Windows 3 on this machine, and DeskView is probably my first choice, just because it works faster. So firstly, let's get to the RAM upgrade. I've used an Intel Aboveboard Plus with 2 MB of RAM in the past. However, I've always had problems getting that card to provide XMS memory. So I bought an AST Rampage card from eBay and fitted it out with 8 MB of RAM in Sims. This was a pretty massive amount of RAM for a 286 machine back in the day. Now I've put 70 nanosecond Sims in the Rampage so that when I go for a CPU speed upgrade, I shouldn't have a bottleneck with the speed of the RAM. The RAM on the motherboard is rated for 150 nanoseconds, so I figured that should be upgraded too. Slower 150 nanosecond memory probably wouldn't go well with a faster CPU. So I sourced 80 nanosecond DIPs and SIMs for the mainboard from my friend Jacob over at Monotech PCs, which were an easy swap-in replacement. Note that the IBM motherboard won't take any other configuration of RAM on its motherboard other than the 512K or 640K, so you can't upgrade to 1 MB or such directly on the board. You can disable the onboard RAM and use a daughter board like the Rampage as the main source of memory if I wished. However, I stuck with the onboard plus Rampage configuration for now at least, ensuring that the memory was fast enough all round. Reading the manual, it seemed possible to get the Rampage to work to provide XMS and EMS RAM all at the same time, which has a handy bunch of uses. However, I found this to be impossible using the AST provided driver. However, when using Microsoft's HiMem.sys along with AST's EMS driver known as REMM.sys, everything started to work just fine. I actually printed out the manual for the Rampage so I could follow along the configuration process. And I can tell you, the manual isn't easy to understand even in 2024, and I'm pretty sure it must have been way above the average computer user back in 1988. For the avoidance of confusion, the way the memory configuration works is that the RAM page allocates XMS first and then EMS. This is likely how most other memory expansion boards that support XMS and EMS at the same time work too. The memory map goes like this, as far as I can tell. In the first part you have 0K all the way through to 512K, which is the onboard 512K SIMs. Then 512K to 640K, you have the onboard 128K DIP chips. And then from 640K all the way through to 1024K is the high memory area, which is reserved memory. This area includes the upper memory block. Some of this RAM is provided by the RAM page card, but most of it is provided in the next area, that is 1024K all the way up to 15872K, which is extended memory, also known as linear memory. Now I have 8 megabytes of RAM in my configuration, so the configuration goes to 8192K, with 4096 of it being split into XMS and another 4096 split to EMS. In theory, the 286 could support up to 32 megabytes of RAM using expanded memory managers, but well, that's just silly for a 286. I got lost thinking about expanded versus extended and all that sort of stuff, so as a reminder, here's what the terminology in a DOS world means. Hopefully I've gotten this right, and if I've got it wrong, well, tell me about it in the comments. Conventional memory, which is the memory anywhere between 0K and 640K, and sometimes this is referred to as real memory. Upper memory block is the memory between 640K and 1024K, usually abbreviated to UMB. This area of memory is generally reserved for things such as ROMs on video cards and network cards. However, if you look at your memory map, there are often areas that aren't being used. So, if you felt cheeky, you could sometimes map this area to program memory. However, I didn't do that this time around. Then there's the high memory area, and this is a small 64K area which is immediately above the 1024K boundary, usually abbreviated to HMA. Then there's extended memory, or sometimes known as linear memory. That's XMS, controlled sometimes or mostly by HiMem.sys, which is available in MS-DOS 5 and above. Then there's expanded memory, and this is known as EMS or LIM memory, and LIM means Lotus, Intel and Microsoft. They all worked on the standard together. There's a couple of standards, version 3 and version 4, which was the most popular one. Now, this memory is usually controlled by using MS-DOS's EMM386.sys, but in this case, with the RAM page, we had to use their REMM.sys driver. EMS memory works by swapping 16K pages of memory in and out of conventional memory, which is a pretty cumbersome method. I believe the RAM page works by allocating 4 times 16K, 64K, frames of the high memory area to be this EMS scratch pad, allowing the rest of the memory to be used for whatever you configure it to be. This turned out to be a really important fact because I assumed that EMS came first for some reason. I thought that the ramp.exe program that I'd been using to configure the RAM page was setting the XMS or linear memory to be after the EMS, i.e. after that 4096K of RAM. Turns out you just have to set the starting address to 640K, so it starts just after the conventional memory space. My friend Jacob from Monotech PCs came to the rescue with that tidbit. I also found that I couldn't use AST's Rampage XMS driver known as rex.sys for that job. The manual reads, rex.sys uses expanded memory to emulate extended memory. You may use emulated extended memory for print spoolers and RAM disks. So it sounds like the AST supplied rex.sys doesn't actually provide usable XMS style RAM for consumption in DOS. It just provides memory for things like RAM drives. Either way, I couldn't get it to serve as XMS, so I gave up on that and used HiMem.sys with MS-DOS 6.22 instead. Ultimately gave me this outcome,
4 megabytes of EMS, which is what we want, and 4 megabytes of XMS, which is again what we want.
Here's what I have in my config sys, just in case you're interested. Note that I set DOS to load in the high memory area, specifically the upper memory block. DOS was able to do this because the himem.sys driver was loaded, and it created a space for parts of DOS to go into. This frees up a little bit more of all that important conventional memory. And I'm sure with yet more tweaking, I could get software like Use UMBS and Quarterdex Memory Manager or stuff like that to get more of the conventional memory. But when I got to 600K conventional, that was a pretty good start for what I needed to do. Next, I had to upgrade the BIOS. A strange thing, you may be thinking. Now, I got the jump on this information, I didn't have to find it out the hard way, from Control-Alt-Reese's YouTube video. Check the link in the description for the details on his video. Now, essentially, IBM, being IBM, decided to deliberately make the system lock up on boot if they saw that the system had been tampered with, specifically on the CPU. So to do this, they made a check in the BIOS, likely to check the speed of the clock signal. As Control-Alt-Reese states, IBM probably did this to stop people from upgrading their cheaper 5162 instead of buying the newer PS2 or even the high-end AT machines. Control-Alt-Reese replaced his IBM BIOS with a generic 286 AMI BIOS from 1990, which he thoughtfully put up on archive.org as he couldn't find them on the internet anywhere. So this was my first shot too at upgrading the BIOS. But for whatever reason, these BIOSes were janky, often reporting the memory incorrectly, and had strange characters appear on the main post screen, before refusing to boot any operating system. So rather than faff around with that, I tried a slightly older 1989 AMI BIOS, which, albeit was a slight bit simpler than the 1991, this one did burst into life. I got this one after doing a bit of Googling, and it was referred to on a website called retrocomp.de. The details are in the description. Now, with the BIOS upgrade complete, it was now time to upgrade the CPU. My 5162 board was a fairly early shipment, dating to 1986, so unlike some of the later boards, my one ships with some slower Intel chips. Later boards have faster Siemens or NEC chips. For example, the clock generator, located at U79, is an Intel 82284-6, meaning it is rated to provide clock signals for the CPU at 6 MHz. Note the diagram here showing that the clock signal of the 12 MHz crystal is divided by 2 by the 82284, providing the overall speed of 6 MHz. The bus controller, located at U68, is a 20-pin Intel 82288-8 chip, meaning it should be capable of running the AT bus at up to 8 MHz. It looks like this bus controller is fed its speed from the 82284, so if the 82284, again which is only rated for 6 MHz, isn't reliable operating at higher speeds, then this could potentially have a knock-on problem here. The original specifications for the AT bus stated that the bus operated at 8.33 MHz, so theoretically this machine should be able to drive the bus, if you pardon the pun, at 8 MHz at least. I've also seen a video by Control-Alt-Reese on YouTube where he attempted, somewhat unsuccessfully, to get the same XT286 going at 10 and even 12 MHz. Whilst I was producing this video, Epictronics shared a video on YouTube where he also worked on a CPU upgrade for the XT286. So there's obviously a few of us that have this rare machine and want to overclock it to make it a little bit less puny. For this video, I've left the original 82284-6 and 82288-8 chips in the machine. However, I have ordered replacement chips that can be driven at faster speeds. But during the time I need to wait for them to arrive, I thought as the machine was already in pieces, it's probably wise to desolder these chips from the motherboard and add sockets so they could be easily swapped in the future. if I want to take the mainboard back to its stock configuration, I can always put the original chips back in the sockets. Now, aside from the CPU clock generator and the bus controller, the 5162 has the following chips, which may also be time sensitive. If I upgrade the clock any faster than 8 MHz, they might not be able to keep up. And this might be why Control-Alt-Reese had some issues. First off, the Intel 8472 is the Universal Peripheral Interface 8-bit slave microcontroller, which is rated at 12 MHz, so I assume it finds its speed by clock divider, which is running at 6 MHz. Then the 8237AC-5 is the DMA controller, which runs at just 5 MHz. It's a 40-pin chip, and there are two of them located directly above the BIOS chips in locations U8 and U9. Next, there's the 8284A clock generator, originally used for 8088 processors, and that's located at U22, top middle of the board, beside a silver 14 MHz clock, from which it takes its speed. And from what I've read, this chip is rated for 8 MHz and runs separately from the CPU, so it probably won't have any major problem if the CPU is running faster than it should be. It divides its 14 MHz clock signal by a third, offers this to the numeric processing unit at 4.77 MHz, and divides this number twice again in half to provide the speed of 1.93 MHz for the programmable interval timer, which is next. The 8254-2 is that programmable interval timer in question. It's a 24-pin chip, which is rated for 10 MHz. So should be okay if I run the machine at 8 MHz at least. Finding a compatible replacement that can go faster than 10 MHz may be a challenge though. And finally, there is a 28-pin 8259AC, which is the programmable interrupt controller, which was actually made for the 8080 and the 8088 in mind, so hopefully that doesn't mind running at faster speeds. But I guess if it did, it wouldn't work at 6 MHz either. The PCXT286 has two of these chips located to the right of the topmost 16-bit ISA slots in locations U59 and U60. So let's have a look at the CPU. The CPU chip inside the 5162 is a PGA or Pin Grid Array socket type. Trying to source a replacement one here in New Zealand got a bit tricky. My friend Jacob had PLCC type chips, but no PGA. Fortunately, Jacob is very handy with a soldering iron, so he made me a PLCC to PGA adapter socket, meaning that I could use the PLCC style chip in the PGA socket and swap chips easily if needed. Jacob provided me with a 20 MHz Harris 80C282 and a 16 MHz crystal. As you may recall, the clock controller chip divides the crystal's clock speed in half. That gives us 8 MHz. So regardless of what the chip is rated for, 20 MHz in this case, this is what we'll get from the CPU, 8 MHz. So armed with the new BIOS, the upgraded CPU, and the faster clock, the system did indeed switch on and boot correctly. What's more is that a speed increase was noticeable straight away as we watched the RAM test count up. Just for a laugh to see what would happen, we thought we would drive it with a 24 MHz crystal, meaning that the system would run at 12 MHz. Unfortunately, but not very surprisingly, the system hung almost straight away. Reverting back to the 16 MHz crystal and running the machine at 8 MHz proved pretty solid though. We started up Checkit, testing the CPU and the new 80 nanosecond onboard memory. The CPU ran at 8.01 MHz, scoring 1991 dry stones. On the memory test, Jacob noticed that 2K out of the possible 640K was not visible. And this was because 1K was being stolen by the slightly old XT IDE BIOS and another by the AMI BIOS for hard drive parameters. So we flashed the XT IDE BIOS to get a newer 2019 version and changed the BIOS setting for scratch RAM to get the precious 2K of RAM back. As we are using more modern crystals than the golden one that comes with the original IBM, the legs are a different size, meaning that they wouldn't fit in the motherboard socket. The solution to get the crystal to fit is a bit of a bodge for right now, but hopefully a more elegant solution will emerge, perhaps for a future video where we upgrade the 2 clock chips. For now, the solution was to add a couple of IC socket legs on the side of the crystal legs themselves. The good thing about this, at least, is it's fully reversible. The crystal doesn't quite snugly fit in the IC socket legs though, but it'll do for now. All in all, this upgrade process has been a roaring success. The next video will attempt taking the machine to either 10 or even 12 MHz, but for now, you can see that I can multitask with Desk View or Windows 3.0 at a reasonable speed and with plenty of RAM. What did you think of this video? If you liked it, please give it a thumbs up. And if you like this sort of stuff, you should really check out the rest of the channel, press subscribe and switch that notification bell to notify you on all of the new videos that come out. I also have Patreon. If you're interested, head over to patreon.com/AlsGeekLab. Anytime a video comes out, it comes out there first. All of the videos are without ads, and there's even some exclusive content. All of the money that I earn from Patreon all goes right back into the channel for new equipment and subscription services such as Adobe. Of course, every single Patreon subscriber I have gets their name coming down the screen, like these wonderful people. Thanks very much for watching this video, and I'll see you on the next one. Until then, you've been watching Al's Geek Lab.